So when we're studying mechanical energy, there are three types of energy that we need to be aware of in our problem solving. Right? And there's another type of energy that we need to be aware of as well, but it's not a type of mechanical energy, but it's one that we need in order to account for what we call the law of conservation of energy. And the law of conservation of energy says that in any closed system, the energy before and after an interaction or process will remain the same. So what that means is we can keep track of the energy, where it comes from and where it goes. Okay, so the types of energy are kinetic. So kinetic energy is the energy something has due to its motion. The symbol for kinetic energy could be Ke. I use K in some of my classes. The way that you calculate it is 1/2 mv squared, where m is the mass and v is the velocity of the object. Another type of energy is gravitational potential energy. Okay, this is the energy something has due to its height. How far from the zero level it is. Maybe not necessarily how far it is from the ground, but how far from the zero level. The symbol could be G, PE, could be GE. I use U sub G in some of my classes. And the way that it's calculated, UG, is mgh. M is mass, G is the acceleration due to gravity, right? That's the 9.8 or 10 meters per second squared. And h is the height. That is how far above the zero level you are. And you can set the zero level actually wherever you want. And then there is elastic potential energy. This is from a spring or a rubber band or something that's being stretched, or a spring that's being compressed. The symbol for this is US. All right, and so this is the energy something has due to stretch or compression. Okay, and then for a spring, for the potential energy of a spring, it's 1/2 kx squared, where k is the spring constant and x is how much the spring is stretched or compressed. And then there's internal energy. Okay, internal energy is already in everything. Everything has internal energy already. But what happens is that through friction or through braking, sometimes there is a change in the internal energy. And so when we're analyzing mechanical energy, work energy as it's usually presented in an introductory physics class, what we're paying attention to is the change in potential energy in a system, right? How much things are heating up or slowing down due to a loss in the mechanical energy of a system. And so that's a brief summary of the different types of energy that we need to be aware of when studying physics, mechanical energy, physics in a basic introductory physics class.